Okay, so here comes part 2 of derivatives. The definition of derivatives, tangent line slope. That's how we're looking at derivatives today. Example number 2 says to find f prime of a, the derivative when x is a, for this function. So we're going to use definition 2 to do that, which says that f prime of a is equal to the limit as x approaches a of f of x minus f of a over x minus a. So here is f of x. Let's just start filling this in. This is equal to the limit as x approaches a of f of x, which is the square root of 2 minus x, minus f of a, that's if we substituted an a for x, the square root of 2 minus a, all over x minus a. So this is what we have. Now we need to simplify this limit if we can, make it look better. And so one thing we can do when we have square roots like this is to use a conjugate and to simplify this down. So let's multiply this by what is a well-chosen 1 of the square root of 2 minus x. This conjugate would be plus the square root of 2 minus a over the square root of 2 minus x plus the square root of 2 minus a. So now we just do multiplication of fractions. So if you multiply the numerators together, the square root of 2 minus x times the square root of 2 minus x right here, we are going to get, don't forget your limit notation, square root of 2 minus x times the square root of 2 minus x is 2 minus x. And then right here, negative square root of 2 minus a times the square root of 2 minus x plus square root of 2 minus a times the square root of 2 minus x. Those add together to be 0. And then the only thing we have left is minus the square root of 2 minus a times the square root of 2 minus a is 2 minus a. And this is all over x minus a times the square root of 2 minus x plus the square root of 2 minus a. Okay, right here, let's distribute this negative. Negative times 2 is a negative 2. Negative times negative is a positive 1. So the 2 minus 2 adds up to be a 0. 2 minus 2 adds up to be a 0. And then if I have negative x plus a. If I want it to look like x minus a, what I can do is factor out a negative 1. So if I factor out a negative 1 from this, that will be a positive x, and this will turn into a negative a. That's what's going to happen there. What did I just do? I said negative 1 times x is negative x. Negative 1 times negative 1 is a positive a. So if you factor out a negative 1, it's the same thing. Then I can see that I could cancel those guys. So this is going to equal to the limit as x approaches a of a negative 1 over the square root of 2 minus x plus the square root of 2 minus a. But now if I use direct substitution and just plug in the a, I get this is equal to negative 1 over 2 times the square root of 2 minus a. Because what happened there is I put in a for x, and then I have 2 of these guys. 1 plus 1 is 2. So this right here is what f prime of a equals to. So that is example 2. Here is example 3. What did they want us to do for 3? 3 says find the slope of the tangent line to this. It says parabola. That is not a parabola. That is a rational function. So that's a little typo. At the point using either of the above definitions. Okay, so either definition 1 or definition 2. What point are we interested in? We're interested in the point 1, 1. So I'm interested in the point 1, 1. If I have to write the equation of a line, I need to know the slope at any point. They told me the point 1, 1. The only thing I have to figure out is the slope of the tangent line at that point. The slope to this curve at that point. So I need to find f prime of a like I just did, only I know what a equals to. It equals to 1. I'm really looking at f prime of 1. So just look at this definition right here. This is what we're going to use. But instead of just using a, we're going to use the value 1. So let's do that. This is going to be the limit as x approaches 1, instead of a, I'm putting 1, of f of x, which is 2x plus 1 over x plus 2, minus f of 1. Oh, what is f of 1? I don't know. Let's plug in 1 wherever there's an x. So again, since they gave it to me as y, if I want to change that to f of x, go ahead and do that. You are advanced enough in math to just switch those back and forth. No problem. So f of 1 is 2 times 1, which is 2, plus 1, which is a 3. 1 plus 2 is a 3. This is equal to 1. The slope, the y value is 1, but they already told me that. I didn't have to go through all that. They told me that the y value is 1 with that point right there. So that's 1 over x minus a, but a is also 1. So this is what we have. Well, now all we got to do is kind of simplify this limit, and this is a complex fraction. And so what I'm going to choose to do is multiply the numerator and the denominator by the lowest common denominator, which is not a mystery. It's this right here. It's x plus 2. I'm going to multiply the numerator right here and the denominator right here by x plus 2 over x plus 2. You're always allowed to multiply by 1. That's why I multiply by x plus 2 over x plus 2. It's going to distribute to each term. So x plus 2 to this term, and x plus 2 times this term, and x plus 2 times the denominator. This is the limit as x approaches 1 of 2x plus 1 over x plus 2 times x plus 2. These are going to get canceled, and I'll be left with 2x plus 1. 1 times x plus 2, nothing cancels, so it's minus 1 times x plus 2 over x minus 1 times x plus 2. All right, let's keep going. The limit as x approaches 1, minus x is negative x, minus times 2 is minus 2. So what do we have up here? We have 2x minus x, which gives us x. We have 1 minus 2, which gives us negative 1. In the denominator, we have x minus 1 times x plus 2. Now we see that we can cancel those guys. Then we won't, that helps us not have an indeterminate form of 0 over 0 anymore. And we're left with the limit as x goes to 1 of 1 over x plus 2. Let's use direct substitution. If I put in 1 for x, the limit as x goes to 1 of 1 over x plus 2 is 1 over 3. This is the slope of the tangent line at the point 1, 1. What's left to do is write the equation of the line. Y minus y1, 1, is equal to the slope 1/3 times x minus x1, 1. This is the equation of the tangent line to the graph f of x at the point 1, 1. We can solve it for y. Y is equal to 1/3 x minus 1/3 plus a 1. Y is equal to 1/3 x plus 2/3. We can graph this line and this function on the same grid like we did a minute ago and make sure that it looks right. So let's just do that. Go to your y equals screen and enter parentheses, your numerator, 2x plus 1, 2x plus 1, close your parentheses, say divided by, open parentheses, x plus 2, x plus 2, and then go to y2 and enter your line 1/3 x plus 2/3. All right, I've got them both entered, and now I'm going to hit graph, and I'm interested in the point 1, 1, so the scale I had before ought to be fine. And it's really, this is what I have right now. It's pretty close up. It's kind of hard to see. It's so close up. So I'm going to change my scale real quick from -10 to 10, -10 to 10. You can do that on a TI by hitting Zoom 6, and it changes the scale. So then you can kind of go out a little bit and see your picture. So this is what it looks like when it comes up when you do that. Now, at the beginning of the class, I said we were not going to be using a graphing calculator for all that much. You can go to Desmos, DESMOS.com, and use the graphing calculator there and do the same thing that I'm doing here if you want to see these nice pictures. Okay, now the last one I'm going to do with you guys, I'm skipping number 4 because I think you guys can do that on your own. I want you to do it on your own. do your best, turn it in. But I want to do number 5 with you because it's a graphing one, which sometimes that throws people. So let's look at number 5. And so what we're asked to do here is to sketch the graph of a function that's continuous on its domain from -3 to 3, where all these conditions are met. So we have a bunch of conditions we have to make happen here. So let's have a look at this. Oh my goodness, this is taking a lot to erase. Okay, let me make some space. Oh, look, I just realized that I have 2.1. This is a 7. It's a 7. Okay. Okay, what are the conditions we have to make happen for G? We have to do this. We have to say G is continuous on -3 to 3. Okay. We're going to have this grid here. All right. So let's just mark this up. This is 1, 2, 3, -1, -2, -3. All right. And then these are the conditions we have to meet. It says G of 0 is equal to 0. It says G prime of 0 is equal to 1. What is G prime of 0? It is the slope of this function when x is 0. The slope is 1, the slope of the tangent line. G prime of 2, G prime of 2 equals to 0. The slope when x is 2 of this function is 0. What does the slope of 0 look like? It's a flat. It's horizontal. That's what that's saying right there. And then also we have a few other conditions to meet. The limit as x approaches -3 from the right of g of x is going to -infinity. And the limit as x approaches regular 3 from the left of g of x is going to 4. Okay. Let's make all this happen. Let's make up a graph. Now, there are an infinite amount of graphs that could make this happen, but they're all going to meet these conditions. So here's one of one that would do that. Okay. So what I like to do when I'm given a bunch of conditions and I have to sketch some graph that meets these conditions is I like to always put in where it's defined if they tell me where it's defined. So for instance, if it tells me that G of 0 is 0, that is 1 point. When x is 0, y is 0. I can go ahead and mark that on there because that is just the truth. So that's not going to change no matter what else is happening. So that's true. So we check that one off. Okay, now, G prime of 0 is 1. The slope of the line, 1 is a positive number, and so 1 over 1 is the slope. So we would rise 1 and run 1, right? So what does this slope like that look like? Well, here, it's going to look like about like this. If you go up 1, right 1, you hit another point. So when it passes through that point, it's going to be at an angle like that. That's the slope right there. What about when it's at 2? Wherever this guy happens to be, what is the slope of a line of 0? It's a horizontal line like that. So when it's going, when it's at 2, wherever it's at, that's what it's going to be flattened out right there. What else do we know? As we're headed to -3 from the right, our function is headed down to -infinity. So here is -3. Let me just dash down here. Let's see what this would look like. So as we're getting close to -3 from the right, our function is going to be headed down to -infinity. That's what this one says, okay? And then what's happening as we approach +3 from the left? As we approach +3 from the left, the limiting value is 4. Let's go up here. This is 1, 2, 3. This is 4. All right, so whatever's happening here, somehow 3 is going to be getting close to 4. Now, it could be a closed circle or it could be an open circle. It was not, it didn't really say. I guess since they gave me parentheses, -3 to 3, I'll make it an open circle just in case. It's not defined there because I don't know for sure. So as long as I have the slope here being like 1, let's just see, what could I do? I could say, okay, it's went through here, it's 1, and now it started to bob or something, it's gonna do this. I could make mine do that, and then it's approaching negative infinity. If I want it to go over here, whatever happens, when I get close to 2, it's gotta have like a 0 slope. How you can make that happen is, if you have a maximum or a minimum, right here, this has a slope of 0. That turning point right there has a slope of 0. Now, there are other places on my graph where the way I chose to draw it, that it has a slope of 0. It has one here, here, here. It didn't require me to do that, but I decided to put them in there, and that's fine. As long as I have a slope of 0 at 2, this qualifies as a graph that met all of those conditions. And I do expect you to have a problem like that on your test. So be aware.